All right, so that should work out a little bit better where I'm not having to swing the turret out here so far in order to machine this part of the casting there. So I'll go ahead and get this. I've still got to lock the rotational direction down, and then we'll be able to pull the turret back some so that we're not hanging out so far for this op. Update on where we're at on setting this housing back up. I have completely reconfigured the way I'm going to put it into the mill. I just finished getting the angle plate indicated this way. We also located the center of the slot right there. And the reason why I decided to do this, we're going to hang it off that direction. I still had to have the turret all the way out here to the maximum capacity with just enough clearance to be able to mill that jaw. And I know what kind of vibration and chatter you can get out of it with just a little bit of a cut. So decided to flip it the other way. Let's go back to make that more rigid for the milling. And this is going to put us within the perimeters that we need to be on clearance here for everything. But I also had to raise it up. So I've got it sitting on matched 1, 2, 3 blocks underneath there. So we raised it up 1 inch so that the housing would clear the mill table there. And like I said, we've already got that trammed in and we are centered up on our slot. So this hopefully is going to work out to be in a good position for us to finish out the milling of the jaw there. So I'm sure you're noticing these parallels bolted there as well, and we'll talk about that, but I decided to put that on there so that I could give myself a plane to work off of to accurately measure this side of the jaw. These are some very precise parallels that I have bolted on there. And we're not out far enough. Got to be careful with raising and lowering the hook really close to the mill so you don't bend or break something, such as our variable speed handle, which is coming right up there on the hook. All right, that looks better. Just got to hold it in place. Forgot to put my hardware over here so it'd be ready. Another mistake. Whenever I'm doing setups like this, I try to remember to have everything that we need for the setup right here in arm's grab so that you can swing it on there, grab the hardware, put it on. Sometimes I just overlook things like that. All right, that should be good. Now these parallels will be pretty close to the knee right there, but I believe that we've got everything spaced so that I can get in here and do the milling without these bumping into the ways, these ways right here. But if it ends up being an issue, I'll just unbolt them and get them out of the way. At this point, I'm ready to just get going on this thing. Yeah, I thought I might have enough room, but I think that is going to end up being a problem right there. I don't know if I'm going to be able to get quite far enough over there. May have to bring this back a little bit further. Okay, I think our setup is going to work fine the way I've got it. I've already got it set up now. We've got to do some milling here, and on this shoulder here, we've also got to step the machine in there. So I'm already past where we got to be going with our cutter. And I believe this is what I'm going to end up using. This is a 1-inch carbide fine pitch roughing end mill. Those are a lot more free cutting than say a carbide insert facing mill, especially since we're going to be doing some of this side milling right there as well. It won't have that beat bang sound, and it won't be shaking around like it will with a sharp cutter like that with an end mill. So I think we're good to go. We've got our parallels there that we can set our height gauge on and be able to easily reference that plane to come up and measure our steps right there. And then we've also got a dimension that will be going from this face here, or the base of the casting, to this shoulder length right there. Okay, here is what the parallels are on here for, so that we have a surface here that we can set our height gauge on to easily get a measurement of where these guys are at. This is already zeroed, by the way. I did that on the granite plate. So we can, you can see it hangs off the back there. That's why I put these out as far as I did, because of the reach. But we can come down here and get a measurement very easily. That says 8.217. I'll move that in. 8.217. I'm seeing what our measurement is supposed to finish at. 7.963. 7.963. Now you can see we've got well over 200. We've got about a 1/4 inch to come off that face right there. So that allows me to easily get a measurement here, just because the bottom that we already milled doesn't come out far enough to be able to get a nice measurement with calipers or micrometers. So I thought that that right there would be the next best solution. And our distance from the base to this step here can be measured with our calipers. We've got machined area all the way up to right there on the casting. So I should be able to reach in here with our vernier calipers like this. I think we've got just enough room that I can come here and get an accurate measurement using our verniers. I'm gonna get this cutter touched off and get to some milling. I like to try to get underneath the outside scale there. See if that'll do it. Okay, let's go ahead and get a measurement here and just see where we're at. So I've got a note up here on the DRO so I don't have to keep walking over and look at the print. I'm calling this my Z since we're measuring up and down. And then our measurement from here to the back is going to be our Y. And I've got a note up here so that I can refer to that very quickly as we measure this. So a Z, we want a 7.963 to finish it. All right, so we've still got, I don't know, less than 100 thousandths what we got to take off of there on our Z measurement there. And my plan is to get it really close with that roughing end mill, and I'm going to swap that out for a different cutter so that we can get a real nice finish on this base right there. All right, so we know we've got a little over 100 thousandths, 110, 11, 12, about 112 thousandths to come off of that. All right, now we'll go ahead and get our calipers and see where we're at on our wide dimension. All right, let's see if we can get squared up nicely on this. And I'm not being too critical. If we're a few thousandths off, no big deal, just getting a rough measurement right now. And that is gonna be, let me get over here so I can read it, 10.435, and we're looking for a 10.352. All right, so we've got a little over 100 thousandths on that face there as well to come off. So we'll get those real close, probably within 10, 20 thousandths, and then we'll swap our cutter out to a smooth end mill and finish it out. All right, let's reach around this and see if we can get us a pretty close measurement on our wide dimension right here. As long as we're within a few thou, that's all I'm really worried about. I just want it to be close. Okay, so we are at, I gotta look at it close here, 10 inches, 435 thousandths. So 10.435 minus 10.352 equals 83 thousandths. I don't like trying to do that in my head. That's why I like having a calculator nearby so that it verifies what it is that you think in your mind. So we'll get that real close. You know, we're gonna have it within I don't know, 10, 20 thousandths, so we can clean that up with a different end mill. But let's go ahead and get it roughed in within 10, 20 on both X and, I'm sorry, Z and Y. This should be the finish of our roughing cut there. I left just a little bit on there so we could finish it. We're looking for a Z 7.963. Yep, 7.977 and a half, 978. Let's just call it 978. All right, so that'll work. That'll allow us to clean up that using a different end mill. And we'll get a measurement here with our vernier calipers. It should leave us about 15 thousandths to come off of that shoulder. 10.375, and we're looking for 10.352. Okay, I think I found an end mill that we can use to finish this profile out here. This is a brand new end mill made by Melon. So sometime back, Melon had actually sent me a few odd size cutters that they had. I'm assuming that these are probably custom made for different applications for some of their customers, and they must have had some on the shelf that had been there for a while that weren't moving. So they just said, hey, we got a few of these cutters, would you like them? And I said, yeah, we can put those to work. So this is one of them right there, and this has got a diameter there of 1.310. So kind of an odd size. Like I said, it's probably a custom ground for a specific application, and maybe it was an extra leftover in their inventory that never did sell or move. So we got a few like that around there from Melon. They had sent a few like that, so I think this will work pretty good. It's got a 1-inch shank on it, and that should finish out our profile that we're machining there. So with it being a 1.310 diameter, unfortunately it won't clean up the entire bottom that we're cutting, because that's 1.33. So we'll have to make 2 passes across there to clean up that bottom, and then we'll clean up the shoulder, and then we still have a step that we got to machine in there as well, about a 1/4 inch depth step, and we'll just use that to cut that step in there as well. All right, so this should work pretty good. We'll go ahead and get it loaded up and see if we can get this profile finished out. Okay, inspection time. This should have been our final pass there, at least on our main step anyway. We still got to come back and machine the small step. We should be able to do that in one pass after this here, but let's see what sizes we landed on. So in our Z, we should be looking for a 7.963. Let's see what we landed on. 7.962. Hopefully you guys can see that in the video there. .962.5. Depends on how much pressure you put on this thing, but it should be 7.962.5. I think we're looking pretty good. 962.5. So I would say we're within 1/1000th of the measurement that we were shooting for there. That's good. I'm going to use a micrometer this time instead of the vernier, and we'll use that. We can just reach around here with our 10 to 11 micrometer and measure that distance there. All right, so I've got our 10 to 11 micrometer here, and if you measure right through this area right here, the frame of the mic will fit, and you can get this thing squared up. It's a little bit awkward to get in here, but we can do it. So let's go ahead and see if we can get us a good measurement on this guy. Just taking my pointing finger, I know you can't really see it, but I'm using my pointing finger just to adjust the barrel of the mic there. Rock it back and forth in both directions to square it up good without over tightening it. And hopefully I won't knock the camera off there. And we are looking for, that is 10.353, and we were looking for 10.352. So according to the mic, we're 1/1000th shy of our target, but that's going to be good. You can't complain with 1/1000 on what we're doing right here. So that's pretty good. We're going to leave this alone. We're going to call this finished here. Now we just need to make one pass across there and finish out that other little small step. So this is what we've been machining right here. This is that extra step that we got to mill in there. There's not a dimension as what we're going to be doing is taking a depth that way. We already have this established at 1.3, but I wasn't sure of the depth because it wasn't on the print. So all I've done is I've taken one of the jaws that actually came off of here, and I've just been doing some measurement. And I can also see, I can visually see that back here, that this face here and this face doesn't actually touch, that it's designed so that it's pulled up against this face. You can see the paint that stuck to it whenever it was taken off. But this thickness right here, the difference is 291,000. So we know that's what we need to take. But measuring this guy with some calipers, just doing some very simple depth measurement right here. This is measuring right at 300 thousandths. All right, and then so if we take 300,000 step there, we know that's going to give us a little bit of clearance on that step, which is what we're going to take. So I'm going to set that at 0.300 deep. Okay, there's our jaw. Let's see if it fits. If it sits on here the way it's supposed to. That looks good. Yep, okay. It's gonna bolt up nicely. And I'm looking down through, we can see just a little bit of clearance between this back edge here and that little step that we just machined. So it will pull down on this face properly there. All right, and there's one more place here we're gonna mill while we're set up. You can see how close the casting is here to the actual working face of the jaw. There is a dimension on the print of from here to here being 0.8, and using the scale there, that's about 15/16 right there in the center of it. So since we're set up good, I already know where this distance is. We're just gonna drop the knee from here 0.8 and go ahead and we'll make one pass across that and clean that up, and we'll have a nice machine surface there as well. And it'll be to the specification on the drawing. All right, I think all that milling is finally finished up there. We can set our jaw up there, and it looks good. Everything is seating up just like it's supposed to. And this is looking good there, so using our rule, now we've got 3/16 between the face of the jaw and this step right down there. So looking good. With the exception of some deburring I got to do on those edges, that's done. Now we can move on to our 2 drilled and tapped holes. We are ready to get this guy finished out. So we're going to move on to our drilling and tapping now. We've already got it located where we need to be. So just so you guys are aware, our center to center distance between the 2 holes is 3 7/8. And then our location is going to be off of this step in the Y direction. That way, 7/8 from this bottom edge up there. And I've got that in position. And if we lay one of our jaws up here, sorry, that right there. Looks like our spot drill is right down the middle of that hole there. All right, so we'll spot them, drill them, and tap them. It did not like that carbide spotting drill running that fast, so we're gonna go to, that's a high-speed steel 1/4 inch spotting drill, and we'll slow it down. Just a lot hanging out there and a lot to cause chatter. We'll slow it down, that's about 600 there. See if we can spot that in a little better. That's better right there. Okay. All right, 27/64 tap drill. What I want to do is establish the full radius there first. All right, right about there. Stop it. What I'm going to do is go ahead and adjust the knee here on the scale. I'm looking up at the quill scale up here. and we want to go 3/4 inches deep. All right. All right, we got our holes drilled and tapped. Everything turned out good. We're going to test fit one of our jaws here. So this is one of the jaws that Jason provided with the castings here. One of the things that I wanted to point out was the counterbore of this is you really don't have a lot of clearance past the face of the bolt right there. It's really, really close, and even measuring it with the calipers, it's within about 10,000. So I may modify this counterbore depth off camera just a little bit deeper, just for like a final assembly, because I'd like that to go a little bit further below that surface there. But anyway, we want to test fit our machined area here for the jaw to sit on. So let's see if it lines up like it's supposed to. All right, that one's screwing in. That one's screwing in too. All right. Touchdown. There's an occasion where I speak a little bit too soon on the touchdown finish, and this is one of those cases here. So let me show you. We need to make one more slight modification. It's one of those things I overlooked. It's not on the print, but I looked at the other vise. So what I noticed when I bolted this down, I came down here and looked here, and I can see that this corner right here is actually hitting, there's a radius right there in that corner. So this is actually hitting, it's not allowing it to pull all the way down like it's supposed to. And I verified that by looking at the other hardtail. There's a bevel that's milled on there. So I'm gonna take a chamfer mill and we're just gonna knock that corner off a little bit, and that should allow this jaw to pull all the way down to the face like it's supposed to and not bind up on that corner there. This is another one of those really nice cutters that Mellon had given me. This is a 5/8 diameter chamfer mill. A nice looking cutter. Solid carbide. It's a 3 flute coated. That should be a pretty smooth cutting chamfer mill right there. We don't need to knock off much. I mean, we'll probably take we'll have a 1/8 inch wide cut across there. I measured the flat across the bevel on the other one, and it's about a 1/16 wide, so I just touched off and moved it in a 1/16, and that should create a really nice bevel there for us. All right, let's try it again. Hopefully we're good now. All right, let me get down here and look. Oh yeah, we're pulling down nice and flat now. Yeah, it is looking good. I can tell that we're seated up here nicely on this face. We're right there, and I can see a little gap there where we cut our bevel. It is good to go. Now we've got a touchdown. All right, guys, well, that is going to wrap up this episode of the Hardtail Vise build. We're going to be moving, or this part here is going to be moving from this shop to my home shop, and we're going to be going to the G&E shaper so that we can finish out the rest of the machining. We've got to reach in here and cut the inside, which is where the dynamic jaw is going to be sliding through. So we have some pads, top and bottom here, that's got to be cut there, and then as well as the chin. So that's going to be a really great process for the shaper, and I think that's going to be some fun video, and I look forward to sharing that with you. But other than that, everything else is done. Our jaw looks really nice, and I'm just happy with the way that everything is turning out. I've been enjoying this project, and I hope that you're enjoying it as well. I've been really enjoying my shop, using my machinery and all of my different tools, and coming up with different setups so that we can machine these parts here. Now, something to keep in mind is that I'm doing this as a fun project. We're not doing this as a production. In a production environment, all of these parts are probably going to be set up on dedicated fixtures that are built so that they can quickly get through the machining of all these components. They'll probably spend some time to build fixtures like this right here that these castings are going to be bolted down to, and most likely every single thing will be done on a CNC machine, which is going to speed up the process there as well. But you can see just by the little bit that we've done on this one casting right here, what all is involved in machining. There's a lot of different areas to machine. There's a lot of different setups you got to do, so you can really see what it takes to build a vise. And we've only just begun this project. We still have a lot more to do on this. So just something to keep into consideration there when you're looking at something like this and the cost that's involved in making a purchase on one. Everything from building the forms, casting them, machining every single component, building it, you know, there's a lot of time that's involved in that, and that's typically where the cost is involved, is in the manufacturing. But as I said, we're doing this for fun, and hopefully you guys are going to enjoy watching this as we get through and keep using all of our different machines and get all these parts cut. I would like to utilize some of our CNC machines here for some of these parts. I got a couple components that I want to machine brand new, and I think the CNC will be great for that. I'd even like to take one of the castings over there to the Miltronic CNC mill and do some machining in that there as well, and show lots of different machining techniques that we can use, from the manual mills to the CNC mill and even the CNC lathe, and old school. Shaper, I even think that the Curdy and Trekker may be involved in some of this machining there as well. And that's what this project is all about, is having fun in my shop and using all of my machines and all of my tools that I have at my disposal to get this project done. And I look forward to sharing all that with you here on the channel, and I hope that you're gonna enjoy it as well. So thanks for watching. I hope you enjoyed, and I hope that I see you again on the next episode.